Okay, hello everyone. Welcome back to week 2 of SAT Math Lecture. To get right into it, we'll start with subtopic 1, which is linear functions. So the first, mini topic in this topic is create linear functions. So we have a question here. For a linear function, h of 0 equals 15, h of 2 equals 14, which of the following equations can be used to represent h? So when you look at a question like this, you have to work with what we have, and we're not given too much. We're given h of 0 and h of 2. Now, we don't have an exact formula to use, so we can use a and b as constants for now and just figure it out from there. So we can use h of x, which represents y, and then a of x. A would represent m, and b, which represents b. So h of 0 equals 15. So we can just plug that in. So we have h of 0 equals 15, and then we plug in 0 into x, and we end up with b equals 15. So we can do the same exact thing with h of 2, but instead we can plug it back in with b equals 15. So h of 2 equals 14. 14 equals a times 2 plus 15. So if you solve it out, a equals negative 1/2. And that so happens to line up with h of x equals negative 1/2 x plus 15. Okay, next we'll be looking at evaluate linear functions. So this is one of the more tricky problems. So you'll end up with f of x minus 1 equals 9/10 x plus 5. For all values of x, what is the value of f of 2 over 5? So the reason this is tricky is because we're not sure if x equals 1 will equal 2 over 5, or if we plug in 2 over 5 minus 1. That is the main mistake here. But what you're supposed to do is f of 2 over 5 will directly be equal to f of x minus 1, meaning you'll have x minus 1 equal 2 over 5. So if you solve that out, x will equal 7 over 5. Then f of x minus 1 equals 9/10 x plus 5. Then you'll just plug in the x we got from before, and you'll end up with f 7 over 5 minus 1 equals 9/10 times 7 over 5 plus 5. So when you plug it in and do the math, you'll end up with 313 over 50. Okay, next we'll be interpreting linear functions. So we have this here. A manufacturing company produces widgets. The company's total cost, C, for producing n widgets can be modeled by the linear function Cn equals 0.1 n plus 50. So what is the correct interpretation of 0.1? Now, if you see here, it can get a little tricky, but we have to remember n is the number of widgets, and C is the total cost. So if you separate each variable, you'll have C of n, which is the total cost. 0.1 n is the variable. So it is a rate, meaning you have a unit over a unit. And then this 500 will be a flat fee cost to produce the widgets in the first place. Meaning the correct interpretation of 0.1 will be, what's it called? The increase in total cost for production of one widget. So this will be because you have the 0.1, and n is the number of widgets. So each widget you produce on top of that flat fee will cost money, and that will contribute to the entirety of Cn. Okay, the last one for this subunit is connect representations of linear functions. So we have this chart here. The chart above shows the average time spent on social media per day by a certain user. The user's social media usage is a linear function of the years passed since 2015. Which of the following equations represents the user's total time h in hours spent on social media t years after 2015? Now, you have to be very careful because they say hours. We want the equation in hours, which greatly changes our answers. Because if you just look on the chart and you take that as face value, you think the slope is 7. But if you look closely, the chart gives us time in minutes, but we want it in hours. So when you do the math, you want to convert the minutes to hours. And because we don't have a very... Because 7 is a prime number, we can't really simplify this fraction, so we'll end up with 7 over 60 hours. So that will be our slope. That is the increase in minutes over each year. And then for B, because we start at year 2015, that will be our base point. So we also have to convert that to hours, where, you just put it over 60. And then you just plug it into the equation. Now, 7 will be our rate because that is the change in slope or the change in minutes per year. And 121 will be our y-intercept because that is the year we first start taking our data, which is why we start at that point. Okay, for subtopic 2, we start off with create systems of linear equations. So we have this question here, which is a very, very, very common question on the SAT. They'll usually ask you something like this at least once. So you guys should be familiar with it and practice a lot with it if it's hard for you to understand. So Marco is selling hot dogs and hamburgers at the school fair. Hot dogs cost $2 each and hamburgers cost $3 each. Marco sells a combination of 50 hot dogs and hamburgers. We don't know how many of each, but he made a total of $138. Now, be careful to read it when you read it because it says how many hot dogs did Marco sell. So we don't really need how many hamburgers he sold. Okay, so when we do the math, we need two variables. I chose D and B for hot dogs and hamburgers. You can use X and Y, A and B, whatever works for you. So, because hot dogs cost $2 and hamburgers cost $3, and he sold a combination of 50 hot dogs and hamburgers, we can set up these two equations here. So, hot dogs plus burgers equals 50, because we don't know how many of each he sold. And then that is the price per hot dog and hamburger with the total amount of money he earned. Now we see here we can use substitution. So we'll just solve for B, which is burgers. You can do it for hot dogs, doesn't really matter. And then we just plug it back into the original equation. And if you solve it out, you end up with negative D equals negative 12. So if you solve for D equals 12. That's how many hot dogs Marco sold. Okay, the next one, solve systems of linear equations. So we have a system of equations, 2x minus 4y equals negative 10, negative 3x plus 2y equals negative 5. So you might get confused here, but essentially we have to use substitution. So if you look here, we have to change one of the equations to match the other. In this case, it would probably be easier to multiply the bottom one by 2, but you could divide the top one by 2 as well. Completely up to you. For me, I'm just going to multiply both sides by 2 for the second equation. So when you multiply by 2, you end up getting negative 6x plus 4y equals negative 10. So we can rewrite our equations like this. So once you decide to add both equations, you can end up just crossing out the y's, and you can do 2x minus 6 and negative 10 minus minus 10, like this. So you end up with negative 4x equals negative 20, and this equation here makes it easy for us. We only have to find x, which is 5. Okay, for our third one here, determine solution conditions for linear systems. So we have this equation here. We have y minus 4 equals negative 3 times x minus 8. And if you look here, it says this system has no solution. So essentially, you guys have to be able to recognize that when there's no solution for two equations, we're working with parallel lines. Now, for this formatting of the answer choices, we can't exactly be sure what the slope is. Because there's more answer choices in the form of x plus y equals blank, we should convert it to that way first. Okay, so we start off with our equation, and we just simplify. You'll end up with y equals negative 3x plus 28. Now, that's exactly the same option as option B, but that would make it infinitely many solutions, so that would make B incorrect. So instead, we should just move x to the other side, and we should see what we would work with. Now, if you guys notice, for answer D, we have the exact same answer, except that one is 3x plus y equals 10, which would make it the exact same line, but parallel, not in the same place, and not making it infinitely many solutions. That's why the answer choice here is D. Okay, for the last one for this section, we have connect representations of linear systems. We have kind of a supply and demand chain here, y equals negative x over 2 plus 115, and y equals x over 10 minus 5. An economist is studying a market for which the above equations represent supply and demand. X represents a quantity, and y represents the price in dollars. At what price does supply equal demand? So you guys have to recognize here, both equations are using the same variables, and because they both equal y, we can very easily set it up to equal each other. You can just substitute y in for either equation. You'll end up with the same result. And we just have to solve for x. So you'll add by both sides. And then to get rid of the x, multiply by 10. You'll end up with x equals negative 5x plus 1200. Then you'll end up getting 6x equals 1200 divided by 6. X equals 200. Okay, just for some solving strategies for common types of problems that you'll see for linear functions. So if you look, you have to be able to understand how to do substitution and elimination. Now, it's okay to prefer one, but you have to be able to know how to do both. Plugging in functions, so you guys have to really understand different notations, like f of x, or it might be a different variable. And then you guys also have to be able to translate what each part of a linear function represents in a real-world context. So, substitution and elimination. We've covered both already, but just for some more practice. Here, we don't really have to change anything. We can just eliminate y. Makes life very easy for us. So, just combine both equations here. You end up with 2x equals negative 6, x equals negative 3. Plug in x to either equation, doesn't really matter which one. I chose the top one, and you'll end up with y equals 0. So the ordered pair that satisfies the equation will be negative 3 comma 0. Okay, for plugging in functions, you guys will be able to have to understand this notation, f of x equals x over 5 minus 4. So essentially, that just means x equals 30 for this problem. So you plug in 30 for x. you end up with 30 over 5 minus 4, 6 minus 4, f of 30 equals 2. Now, this is more of a simple problem, but you guys will have to be able to understand this notation for possibly real-world problems, more complex ones. So we don't want to make mistakes on the easy questions. Those are pretty much free points. So we want to be able to get as many of those correct as possible, okay? Okay, for our last example here, we have the translation of these equations. So you guys will have to be able to understand that the retreat rate is a rate which usually has that variable there, which is x. So if you look at the retreat rate, you guys will have to look at, in context, what is happening to f of x, which is what we're looking at. In this case here, f of x is the total amount of kilometers. So we want to rate kilometers per year, and it says retreat. So we can attribute that to a negative 0.6x, and the length was 66. Now, because we're retreating, we're getting smaller, that means we'll add 66 instead of subtracting 66, which would make our answer choice A. Okay, again, if you like this lecture, please like and subscribe, and we'll see you again next week.